And let's just take a look at this cheat sheet, for example, right? Essentially, when we're doing vectors and you want to find the resultant of two vectors, and when we're talking about that resultant thing, you could think about it like two forces, you know? If I have a force moving so and another force moving so, and they're following each other, then you would use your triangle law to find the resultant. However, if I have a force moving in two opposite directions, they're pulling away from each other, that means the resultant would go this way. You would have to use the parallelogram law to find the resultant, right? So it's only when you're finding resultant, right, is when you just have to use this triangle law and parallelogram law, right? We also remember this thing about negative. So remember A plus BA going in this direction, plus B which going in this direction, but as you can see, B is the opposite direction, so I could say negative B. Because B is the opposite direction, then going in the blue direction would be negative B, the opposite way, and that would give me C. You can see that's an application of the triangle law there, right? Then we could also use the this kind of thing in terms of the addition of vectors to translate like a point from A to B using a vector. Similarly, you know, that is a similar thing when we had vector displacement. That is when we had these vectors going like that, vector A, well, at the point A and the point B, and you wanted to find out how do you get this vector that translates A to B if you have both of them coming from O, right? And that is when we talk about the displacement of vectors, right? And you can see that, guess what? All of these things might seem different, but it is all boiled down to your triangle law and stuff anyway, right? We saw the modulus of a vector, which is how long a vector is. And if parallel vectors, you have to have the scalar quantity here. You see how good it is to have a cheat sheet? You can literally just revise the entire topic in 2 minutes, right? Position vectors, a point, like the point A, could be seen as a position vector from the origin, 2, 4, right? And we've never, and this is on the curriculum, but I've never seen it in a question, right? And that is to find the angle under the vector. I think we did see it in one question, I think, right? Which is you put the y over the x, or in that case, the vertical over the horizontal, right? The opposite over the adjacent. In this side here, we have the unit vectors, and unit vectors is just another way of writing vectors. So we have the vector AB, which is 2, 5. You can see the x value, we write that as I, and the y value, we write it as j. So it ends up being 2i plus 5j. And this is just another way that you can work vectors, yeah? And when you're adding vectors, you would obviously add the i's together, and you would add the j's together, just like how you would add the x's and the y's together, right? And then we spoke about collinear, and for collinear, you just have to prove that they are scalar multiples of each other, so that will show that they're parallel. And if they have a common point, that means that it's impossible for them to be parallel, because parallel lines don't touch, so they have to be collinear, in the same direction, part of the same line. So this is the cheat sheet. This is the entire topic of vectors here, mostly. And let's see how that helps us. Right? That's all we really need to know, you know, just that stuff. Right? In the diagram below, the coordinates of point P and Q are 2, 4, and 8, 2. So, okay, let me identify what's going on. And you see how I just read it. I am reading the rest of it. Alright, so that's P, 2 over here, 4 over here, I could see that, and that's Q, 8 and 2, okay, no problem. The line segment joining the origin 0, 0 to the point P can be written as OP. Okay, thank you for telling me that, question. It doesn't really help, but I guess you're telling me that P is a position vector. So OP, this is the position vector for P, and then you have OQ, the position vector for Q. All right. So I hope that that's okay with everyone so far. All right. What term is used to describe OP? 2 marks, 1 mark for position, the other mark for vector. All right. It's coming from the origin. It's a position vector. Now that's the term used, right? Write each of the following in the form A, B. So we can see OP is the 0.24, and from the origin that means that it is the vector 24. OQ is simply the vector 82. And PQ, well, PQ here, it have many different ways that we could do PQ. We could find PQ as a translation. P plus some vector x will give us Q, right? We could do that, but really and truly we could just look here and see that, okay, on the x, P is on 2, and Q on the x is on 8. So the difference between 2 and 8 is 6. So 6 on the x there. And on the y, P is on 4, 8 is on 2. So the difference between them is 2. But remember, P to Q is going down. They're going down from 4 to 2. So that is -2. All right, look at the direction. In this case, from P to Q, because this is what we want, P going to Q. So from P to Q, the x value is increasing from 2 to 8. So that'll be a +6. But from P to Q, the y values are decreasing from 4 to 2. So that is -2. So 6, -2. Scotia, Shazay, Soraya. You understand what I just do there, or are you confused? Yes, it does. But you didn't work it this way. Did you get 6, -2? Right. So imagine this. You're adding 0, well, not 0, but OP plus OQ. Right? So you adding OP plus OQ. So what you're saying there is you're adding OP, which is this direction, plus OQ, which is this direction. You understand what you're doing there, Scotia? Right? Now, you can see that you can't really add them because they're going in opposite directions. So it's not like you could just add them. You can see here that they both are pulling the carriage. So you'll have a resultant going in that direction. Yeah? And we could call that the point R, right? So the only way you could add, and remember when we add in triangle law, I mean, this doesn't cancel with this, yeah? Okay. Remember, if you wanted PQ, Scotia, and this is the thing, like, and I keep saying it over and over, right? I keep saying it over and over. You have to think about it like if you're driving. And it's direction, and this is the same mistakes you made last time. What do we want? We want PQ. So you are driving from P to Q. So you're driving from P to reach Q. You get what I'm saying, Scotia? Right? So at the end of the day, if you're driving from P to reach Q and the road blocked, then you had to drive from P to O and then go from O to Q. You get what I'm saying there? So you could see here that it could have worked like that. P to O plus O to Q. Right? You can see here that these two are the same, so that they kind of cancel, and you'll get the answer P to Q. You see in that, Scotia? So you're seeing how what you did here was a misconception of the triangle law, right? And the reason why you had the misconception, the same mistake you were making in the last class, is you wasn't looking at this as P to Q. You had a drive. You understand? Right? You just kind of was looking to add random things because you wasn't really understanding. So I'm actually not convinced that you understand this topic, Scotia, right? I would invite you to see if you could try to go and look over those videos, right, and see if they help, yeah. Or you could just ask me; it's no problem, right? So if we work it out this way, we could see that OP is 2, 4. So therefore, we want PO. PO is the other direction, not PQ. PO. PO is the other direction, so it will be minus 2, 4. You get what I'm saying, Scotia? Yeah. So because OP, you have to look at those directions. The direction from O to P is 2, 4. So if you're going in the other way, it'll be minus 2, 4. So this PO is minus 2, 4 plus OQ, which is 8, 2, right? And that'll be 8 minus 2, right? Because this is a negative in front here. So 8 minus 2 is 6, and 2 minus 4 is minus 2. So you see what went on there, Scotia? You okay? All right. Soraya, how you feel about all of this? Because this is a little bit beyond you, right? But it should be easy enough. Yeah? Right. So Scotia, you see the mistake you're making there. I don't know if this is the mistake, but to me, you looking at PQ as the line PQ, right? But no, this PQ is, it stands for something. The reason why P comes first is because you're starting with P and you're going to Q, right? So PQ we saw there was 6, negative 2. But if we had QP, you see we're starting from Q and going to P, so we're going in the opposite direction. So it would be negative 6, negative 2. You okay with that, Scotia? Alright. So when you're doing vectors, you wanna look at those directions and see if what you're doing making sense, right? You can't just have OP plus OQ in terms of just adding it just so. It has to make sense in terms of why, right? So given that OP, all right, so I see in here OP is 2, 4. I even read the question yet, I just mean is equal to RQ. Okay, where's RQ? I don't know where's RQ, but let's see in here RQ. Okay, all right. Determine the coordinates of the point R. That is interesting. And I know where R is here. I know where R is. R is the resultant. Because you have this pulling this way, you have this pulling this way. So that means your resultant gonna end up coming so. And this gonna end up being R. Yeah? And that way you have to do your parallelogram law, right, where this is parallel to this and this is parallel to this. So what they're saying here is OP is the same as RQ. RQ is this side here, right? And if they're equal, that means they have the same direction. That means that they're parallel and they have equal length and everything. Yeah. So that is what that means, right? And I could kind of see that already, that parallelogram law might have to play a role here. Determine the coordinates of the point R. So they want to know what these coordinates are here of the point R. Scotia and Shizzy, any ideas of how? And I have many ways that I could do this. Any ideas? Shizzy, let's start with you because I've been bullying Scotia for the past 10 minutes. Anyway, any idea how to find that point R? OP and OQ. That's pretty much it. And if you add an OP and OQ, you would find OR, right? But remember, is OP and OQ is parallelogram law, so you can't really. I mean, technically you will be adding them, yes. But yes, that is one way, right? So one way that we could find R is we could use the parallelogram law. We see in here that we want to find this resultant. Actually, no. It's correct, but it have any other ways? Maybe. That correct. We could definitely use the parallelogram law, yes. But are there any other ways? And I'll do that parallelogram law one just now. Any other ways? They have a point R, OP. So OP, right? Think about it. Think about it. Scotia, you see how to find this one, PR. You see how I didn't do no work and I literally used my graph? You saw that, Scotia? And you understand the process I did to do that? Right? So you don't think we could do that again here to find R? Because the telling me here, OP is the same as RQ. So RQ probably had to be like that. So the point R gonna end up here. So OP is the same as RQ. So if it is that I say, well, okay, from O to P, I had to go 2 spaces, 1, 2, and then 4 spaces up. 1, 2, 3, 4. I'll get 2, 4, right? So wouldn't this vector be the same vector 2, 4 as we see in here? RQ is 2, 4. Well, really, QR is 2, 4, right? And this is why CSEC is some real dotish people sometimes, because that is super confusing, yeah? Because RQ is not 2, 4. Actually, RQ is negative. It's in the other direction. But you kind of had to make that out, you know? So I have QR is 2, 4. What if I just say, well, all right, from Q, I move 2 spaces, 1, 2 on the X. So that means that R is going to be, if I move 2 spaces, 1, 2, 8 gonna become 10, and then I move up 4 spaces from 2, so this is 2 here. If I move 4 spaces, 1, 2, 3, 4, that means that this is gonna become 6. So the point R is actually the point 10, 6. So Scotia, do you understand the reasoning I just did there? Right? What do you mean kinda? What was confusing? So they told me that OP and RQ are equal, right? Determine the coordinates of the point R, right? Well, OP, right? We know OP is 2, 4. What is 2, 4? That is the vector that is take O to P. And they tell me that RQ and this is why they wrote it wrong. So this is one way, 10, 6, right? Let's do it Chazet's way, right? And see if we get back the same 10, 6, right? Chazet said to use the parallelogram law because I have OP and I have OQ here, right? And this is going to be the resultant. And that resultant is R, right? And that means that I'm gonna have this parallel line here. So this here is parallel to this, and then this here is parallel to that. Nice. So in terms of the parallelogram law, I can't just go adding OP plus OQ. I cannot do that. The only way that I could add vectors is if the letters line up. So like, let me just say PQ plus QR. You see how these two are the same? So they cancel out. That is what you want. You want that so that you could get PR. Yeah? So you could see here that because these vectors are going away from each other, I have OP plus OQ. I can't do that canceling out thing. It doesn't have that here. But because of the parallelogram law, I see in here that this vector PR is the same as the vector OQ because they're parallel, they are equal, right? So now I could say, well, and it's the same thing, it work out to be the same thing, OP plus PR. Yeah, and now you see it'll work. These two will cancel and I will actually get OR. Right? But remember, PR is the same as OQ. So at the end of the day, if you had added OP plus OQ, you would have gotten the correct answer, yes, but this statement here is wrong. Right? OQ is the same as PR, so this here is correct because I could cross off them P's and I'll end up get OR. So OP being 2,4 plus PR. PR is the same as OQ, so that is 8,2. And that here gives us 10,6, which is the same thing that we got before. Right? So Scotia, how you feel about this one? This is the parallelogram law.
Okay.
Right? Is okay? And Scotia, I just want you, because I notice whenever I'm doing it on the graph, and I'm sorry for picking on you, Scotia, but I only have 2 people in my class, well 3, right? But at the end of the day, the easiest way that I do it is the way that you seem to be having the most problem, right? And that is just looking at the graph and looking at the points, and the points just kind of give you the answers, right? Because if it is that I wanted to find PQ, that means I go in from P to Q, right? And if I go in from P to Q, I look at my X value, that means I go in from 2 to 8. So if I go in from 2 to 8, I'm moving up 6 plus 6. Look at what my Y value, I go in from 4 and I go in down to 2. So that means that I am minusing 2 from the Y value. Right? And I get that. Do you understand what I just did there with the graphical method, Scotia? Alright. Well, that's exactly what I did to find R. Right? And I'm sorry, I have to say sorry on behalf of CSEC, because CSEC wrote this question stupidly. Right? They should have said QR is the same as OP, but they have RQ. I wish I could find the person who wrote this question and clout them. Right? I use the same method, right? Because they're telling me here OP, which is this here, is the same as QR, which would be this. You understand that, Scotia? Because they tell me that, right? They tell me that over here, right? So if they are the same vector, that means that this is the vector 2, 4, and this is the vector 2, 4. You understand that, Scotia? Right. So that means that if I want to go from 0 to P, I would have to move 2 spaces horizontal and 4 spaces vertical. You cool with that, Scotia? Right. So that means that if I wanted to go, because OP is 2, 4, right? And this is it. This is where your problem is, the fundamentals of what vectors mean. Because remember, O is actually the point 0, 0. That is what O is. So you're going from the point, and I shouldn't write it like that, I should write it like this. The point 0, 0 to the point 2, 4. That is what OP is. You're going from O to P. You okay with that? So in order to go from O to P, from 0, 0 to 2, 4, you had to move 2 spaces on the x-axis and 4 spaces on the y-axis. And isn't that what 2, 4 means as a vector? So you understand how you go from O to P, right? You go from O to P by moving 2 spaces and 4 spaces up. But look, this here is the same thing, isn't it? Isn't this 2, 4? Right. So if that is 2, 4, and yes, I'm picking on you today, Scotia, right? If that is 2, 4, it's just that I'm not starting with 0, 0. I'm starting with 8, 2. Yeah, because I'm going from Q this time, and this is 2, 4, right? So from the point 8, 2, I'm gonna add 2 to that 8. Yeah, because I'm moving 2 spaces horizontal. So I'm adding 2 to the 8, and that'll give me 10. And then I'm moving 4 spaces vertical. So I'm gonna add that 4 to that 2, and that's gonna give me 6. So you understand how I use the graphical method here, Scotia, right? And I think one of the problems with you, Scotia, is you're overthinking it. It really is this easy. It really is this easy. I mean, vectors is an easy question. So this is what, 10, 6? Yes, 10, 6 here. And it have yet another way. So we use 3 ways to work it out. The first way is we use the graphical method, and we just read the graph here. This is 2, 4, and we can just count and we get 10, 6. All right. Then we use Chazé's way of using the parallelogram law. So the parallelogram law, where Chazé wanted to add OP to OQ. He wanted to add OP plus OQ, but you can't do that because these have to be the same. Right? So that is why we have the parallelogram law to show that this side is the same as this side. So now we have them as the same, and now we can add them. Yeah. So these are the 2 methods, and then I have one more method. Right? The one more method is this. Vectors as a translation. They're telling me that this OP24 is the same as QR, which is also 24. So that means that the vector Q, sorry, the point Q plus that vector QR is going to give me the point R. Vector as a translation. So the point Q being 8, 2 plus the vector QR is going to give me the point R. Oh, but normally we do this to find the vector, but in this case we have the vector 2, 4, right? And that gives me 8 plus 2 is 10, 4 plus 2 is 6. So we do it in 3 different ways, right? We do it in the graphical way, we do it in the parallelogram law way, and we do it in the vectors as a translation way. Right? How do you feel about all of these 3 ways? And I will ask Scotia first, since she's already so annoyed.
Okay.
Right? You understand all 3 of them, right? So your problem is application. You don't know what to apply where, but you're seeing that it has so many different ways to do it. Right? It's just a matter of being able to reason it out, because as you could see, each one of these ways I was able to reason it out. It's not just a matter of adding OP and OQ for adding its sake. You know, no, you have to recognize certain things. You really have to know the material. Yeah. So we have the point R, and the point R is 10, 6. Okay, so the point R is 10, 6. Right? So state the type of quadrilateral formed by P, Q, R, and O. Right? 2 marks. Justify your answer. P, Q, R, and O. And this is why I hate CSEC. Look how they write this. P, Q, R, and O. In a vectors question, you telling people to go and look from P to Q to R to O. That is what you're telling people to do. No. No. You're supposed to tell them, you know, you could tell them P, R, Q, O, or O, P, R, Q. Let them trace the parallelogram now. oh gosh, you know. But what type of quadrilateral is formed here? This is a parallelogram. So number 4 is a parallelogram. They say justify it. Well, okay, justify. Given, right? O in part 3, we were given that OP is equal to RQ. Right? Stupid people. It's supposed to be QR, you know. But we were given this, and therefore they are parallel. Right? Therefore they are parallel. OP, if OP is equal to RQ, then they would be parallel. Right? And again, OQ is equal to PR, and therefore parallel. Easy, 2 marks there. Alright, that's enough buffing Scotia. Let me buff Shazay now. Right? We have this question here. So Shazay, how you did in this last question? Did you get it correct?
Yes.
The whole thing?
Yeah.
For real?
Yeah.
Oh, okay, my boy representing. Alright, okay, my boy representing. Alright, so good job there. And Scotia, you don't worry. I know that it's just a lot in your brain right now. And that's kind of how vectors is. But it's actually quite simple, right? The position vectors. Well, I see position vectors. So I'm thinking from the point O. I'm thinking from the origin. Okay. Of the points P and Q relative to the origin O are OP is 4, 3 and OQ is 5, 0. Okay. Right. And I mean I could draw the sketch, but they already have a sketch here. But just for me, O is 4, 3, 1, 2, 3, 4 and 1, 2, 3. That is P. And then OQ is 5, 1, 2, 3, 4, 5 here. And 0, so it's not going up or down, it's just staying right there on the x-axis. Yeah, so I have OP and I have OQ, and that is what I see in here. I see an OP and I see an OQ. Scotia, you okay with this so far? Alright, yeah, so Scotia, I'm gonna be asking you a lot because you're usually one who have a little bit of trouble with it, so I just want to make sure that you're following everything, right? You notice I even read the question yet, eh? The diagram below shows that PR, okay, which one is PR? P to R, okay, what happened to PR? Is 3 times OP, okay. So whatever OP is, this will be another OP, this will be another OP, and this will be another OP. Because this distance, this distance, so PR is really just OP 3 times, okay? And QS, this is Q and this is S, is 3 times OQ. So QS is just OQ 3 times. OQ and OQ. Scotia, you okay with this so far?
Yeah.
Alright. Did you get this though, or did you make the mistake here?
Yeah.
Alright, no we didn't. I just talking about the reasoning. Because you see how much information I put down there and we are even answering nothing yet. Right? I'm making sure I am very clear about every word, which is why I hate them CSEC people. Because they don't do that, right? They just make mistakes in these questions all the time. So express in the form xy the vector OS. So OS, where is O? O is here and S is here, right? Well, I know that OP, well, I see here, which is QS, right? Well, we can see here OS is 4 OQs, and it's 4 of them, right? So I could tell here that OS is actually 4 OQ. And you notice how my diagram, because a lot of people would have put 3 OQ. But no, 3 OQ is actually QS. That is not OS. So OS, you had to add another OQ, right? So 4 OQ is 4 multiplied by where's OQ? 50. So that will give us 20, 0. So this here is the point 20, 0, the point S there. Right? Scotia, how you got that? You got that one?
No.
Alright, that's okay. That's okay. All of these no's are okay because, you know, we had to get all of these things wrong. We have to get them wrong. Getting them wrong, we just learned so much. What was the mistake you made there? You multiplied by 3. And you saw why that was a mistake here, right? Yeah. Alright, so you understand. Good? Yes. You see, I know that mistake what I made, but you see why it is that I take my time and I draw out on the diagram. I make good use of my diagram, right? And I make sure I understand everything properly before I even start to answer the question. When you do that, all of the answers is just kind of be there for you to just pick out, right? RS is here to here. Huh. Well, R to S, and this is how much points. Do they have the marks here? No, I didn't have the marks here, right? So in order for me to find the vector RS, I know that S is 20, 0. I know that Q here is 50, the point Q, because it's all position vectors we're dealing with, and the point P is 4, 3, right? So I could find the point R, right? So first we could find the point R by saying that OR, because once you're coming from the origin, you actually could find the point, right? OR is, if you look at it here, 1, 2, 3, 4 OP. And you can see it plainly on the diagram. Right? Remember they said that 3 OP is PR, and then you have another OP, which is OP. Right? So you'll get 4 OP to give you OR. So therefore, OR is 4, OP is 4, 3. 4 4s are 16, 4 3s are 12. So the point R is 16, 12. That is OR. And remember, once you're coming from the origin O, that next one there is actually the point. Okay? So we have the point R, 16, 12. And we go in here to 20, 0. Right? So what is RS? Well, it have the many ways that I could do it. Yeah, the many ways that I could do it is, first way is the graphical method. I could just literally look at the points. I go in from the point 16, 12 to the point 20, 0. So you can see that, look at the x-axis. To go from 16 to 20, I have to increase that way by 4. Right? So obviously RS is going to be 4 on the x. And in order to go from 12 on the y to 0, I will have to go minus 12. That is 12 downwards. Right? So the RS is actually 4 minus 12. Scotia, you okay with this? You sure? Alright. I know you don't like that graphical way. That's why I keep doing the graphical way. You understand how I do it, right? Right? Shazay, you got all of these answers so far?
Yes, sir.
No?
I went to all from 1 because I multiplied by 1.
Like you multiply by 3 too. So you make the same mistake. That is no sin. I understand that. I'm glad that we make these mistakes. Alright? At the end of the day, it's not just about knowing your work here, it's how you read the question. And you notice, when I start, I just read this here first, and I read here, and then I stop, and I went and I check. and then I read this and I read this and I draw my diagram just to see how it will look, and I try to understand it on this diagram here. You know, I don't ever just read down a question, rah, 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 rah. No, yeah, piece by piece, right? So RS is this, and of course there is another way. They have two other ways we can work out RS, right? And I'll just do it for the sake of it. The first way was the graphical way. The second way is I could take the point R. So the point R plus the vector RS, which is what I want to find. I don't have the vector RS. And that will give me the point Q. This is vectors as a translation. Okay? So now we can see that the point R, which we worked out to be 1612, plus RS, which is the vector we want to find, and that is equal to the point Q 20, 0. And guess what? This works out to be the same thing that we did in the graphical method. Yeah, we just throw across the 16, it'll become minus 16, so 20 minus 16 is 4. Right? Throw across the 12, it'll become minus 12, so 0 minus 12 is minus 12. And we get 4 minus 12 for RS. So that is the vector as a translation way of doing it. And then there is also the triangle law way of doing it, which might confuse your head a little bit. But we want to find RS, so we want to drive from R to S. So that means that we have to drive from R to O, and then from O to S. So we can see here that RS is equal to RO plus OS. And you notice these two are the same, and you'll get, this is the only way that you could do a vector addition. If you don't get these two canceling off, then you cannot do any addition there, right? Or you shouldn't. So we can see that RS is RO. Well, OR is 1612. So RO going to be negative 1612. We're going in the other direction. Plus OS, where OS is 20, 0. And look how it works out to be the same thing. 20 minus 16 is positive 4. And then I have 0 minus 12, which is negative 12. 3 different ways to get the same answer. Scotia, you understand all the 3 ways I used here? So state 2 geometrical relationships between PQ and RS. PQ and RS. This here is 1612. This here is 20, 0. And you see how I just go piece by piece and try to figure out everything. I just move like a real dunce when I do in a question. I just pretend like I was a simple-minded person, and the answer had to be something simple. So state 2 geometrical relationships between PQ, P to Q, and R to S. I have a feeling that I know where they're going with this. So I see RS. We know RS is 4, negative 12. Let's find PQ. And PQ, we could just do it the graphical way. In order to find PQ, I could go about these 3 ways as well. Just looking at the graph. Or I could do vector as a translation where P plus the vector PQ will give me Q, the point Q. Or I could do the triangle law here. PQ is PO plus OQ. But I'll just do the graphical method. And we could see here that what do I want to go from? P to Q. So let's look at the X value. I'm going from 4 horizontally to 5. So that means that the X value is 1, right? And then I'm going down from P, I'm going down 3, and I'm going down here to 0. So that means that this Y value is negative 3. Yeah, you're okay with that, Scotia? Alright, so this is 1, negative 3. Where's P again? 4, 3, and 5, 0. 4, 3, 5, 0. Right? I haven't eaten since lunchtime and I'm quite hungry now, right? So we have 4. So this point here is 1, negative 3. Okay, alright. So can we see, we have RS is 4, negative 12. And we have PQ is 1, negative 3. Any relationship between these two? Alright, so RS is really 4 times PQ. Alright, so RS is 4, negative 12. And what is that? That is 4 multiplied by PQ, which is 1, negative 3. So 4 times 1 is 4. And 4 times negative 3 is negative 12. And so the two geometrical relationships, number 1 is that they are scalar multiples. And then number 2 is that they are parallel. Nice. So I'll give you guys, how much time? 5 minutes. 5 minutes on this question here. Please read the question really carefully. Take your time, nice and slow. 5 minutes. Alright, well, let me get started with it. And hopefully Shizay will catch up, right? So we have here, let's see, I see a diagram here, looking diagram-ish. Let me see what they say. OK, so O and K, and I see an O here, so I'm figuring there's an origin of some kind. And OM, so I have O and M. Our position vectors, okay, well, position vectors means that O is in fact the origin 0, 0, alright? Such that OK is equal to K. Remember, we could call a vector by just a smaller name, so OK is K, and I'll just zoom in here, right? And you can see the K a little better. And OM is M, so this whole thing is vector K, and this whole thing here is vector M. Alright. Sketch the diagram above. Well, alright, I'll just pretend that I sketched it. And show the approximate positions of R and S. Okay. Such that R is the midpoint of OK. Alright. So if R is the midpoint of OK, this is OK. So therefore R would be in the middle. Alright. And therefore this OR here would be a half K, wouldn't it? Right? It'll be a half K. OR is actually a half of OK, which is a half of small k. Alright, cool. So you notice I just kind of making sense of the entire thing before I even go with the rest of the question, right? Then I say S is the point on OM such that OS is a third of OM. So S would probably be about here, so S. So OS is 1/3 OM. So OS here, right? And this is starting to look like a question that we were just doing, honestly. OS here, this is actually a third of M, right? Because OS is equal to a third OM, therefore that is a third of M. So Scotia, we didn't answer no questions yet, I guess. Well, yeah, I guess we did. This is a 2 marks here. But did you get this? Oh, but you know what? That might have been my fault, because I probably should have zoomed in a little bit more. You know, I was hoping that you guys were able to see it clearly. So I'll take the fault for that, Scotia, right? Because this is big K over here, right? But hopefully, you know, you could get the answers correct, right? But you understand what I did here, though?
Yeah.
That makes sense, right? Right. So, alright, so we have that there. Now let's see. Write down in terms of k and m, small k and small m, the vectors mk. So let me start with mk. Mk. So mk. So where is m first of all? M here and k here. So you notice they didn't say km, they say mk. So they're moving in this direction. This is the direction that we move. Mk. So mk, well, I want to drive from m to k, but the roadblock. So I'll have to go from m, I'll have to go to o, and then from O, I'll have to drive to K, right? And that will give me MK. Right? I see here that, remember, OM is equal to small m. So therefore, MO will be equal to negative small m. You understand that, Scotia? Right? So therefore, MK is equal to MO, which is negative small m, plus OK. OK is small k. So therefore, MK is really just k minus m. You got that? That's fine, that's the same thing. But we have to learn how to practice our associative and commutative laws. Yeah? Because it is, even though it is the same thing, it is considered good manners to put it like this. Yeah? You know? But it is the same thing though, right? So MK is k minus m. Right, k minus m. Let me just write that a little bigger there, even though it's small in the whole thing. K minus m. Nice. What do I want next? I want Rm. So Rm. Alright, well, let me just put this. I want to put it in a place where it wouldn't humbug me, but I'll still see it, because I might need it. So what do I want now? Rm. Rm. So Rm is from R going here to M. And if I want to drive from R to M, but the road block, I could go two different ways. I could go RK, KM, or I could go RO, OM. And let's go that way. Let's go RO plus OM. And we should get the same thing. Right? So RO is negative a half K. Right? Because we can see OR is a half K. So RO will be negative a half K plus OM, which is just M. So therefore RM is M minus negative a half, well, negative a half K, or K on 2. So Scotia, how you do with this one? Okay, how come? Do negative a half K?
I just have half K.
A third of M. But why a third of M? Did you understand what I just did there though? So what was the mistake that you made? Did you not know where M was? Even if you had used this as being M, you should have gotten the same answer, right? Even if you had done it like that. Right? Let's go look at the other one. KS. KS. So wait. This here is k minus m. This here is m minus k on 2, right? And what do we want now? Ks. Ks is from here to here. Ks. If I want Ks, I can't drive to Ks. So I had to drive from K to O and then O to S. So Ks is KO plus OS. And you just see in here, this is a whole bunch of triangle law. This whole question is just triangle law, right? So from Ks, I go KO. Now, OK is small k. So KO going to be negative k again, plus OS is a third m. So the answer going to be a third m minus k. What about that one, Scotia? You're stuck on that one? How come? What stuck you? About? Alright, what was the first thing that you did when they said KS? What's the first thing? Did you draw this KS here?
Yeah.
So RS is, this is the point R here, and this is the point S here. So RS is here to here. So I could see that I want to drive from R to S, but I can't get there. There's the roadblock, so I'll have to pass on the next road. I can go from R to O, and then from O to S. R to O plus O to S. Right? So R to O is negative a half k, plus O to S is a third m. So now I have a third m minus a half. Right? So Shazzy, are you back with us?
Yes, sir.
Did you get these things here?
Yes, sir.
Alright, lovely Shazzy. Right? And Scotia, I think that if you just try to read your question a little, take your time and read your question. I don't think your problem is the knowledge and application. I think your problem is understanding the question, right? So let's see if we could do this one on the fly. Let's see if you guys could do this literally in class right here. L is the midpoint of Rm. Alright, so let me find Rm. R, this is R, and this is M. So I guess this here is Rm. And we saw here that we found Rm to be m minus k on 2, which we have here, right? So small m minus small k on 2, that is Rm. Using a vector method, prove that Rs is parallel to KL. So what they say in here? L is the midpoint of Rm. So L is here. This is L. L is the midpoint of Rm. So I have to prove that Rs, so Rs here, this is Rs here. This is Rs. And I have to prove that Rs is parallel to KL. So this is KL here. I have to prove Rs is parallel to KL. How do I do that? How do I prove that Rs is parallel to KL? Shazzy or Scotia, or anybody, Soraya, Caitlin. How do I prove Rs? What do you know about parallel? What do you have to do to prove that two things are parallel? That's all. That's all, right? So I have Rs. Rs is this, a third m minus a half k. That is Rs. I don't have KL, so I guess I'll have to find KL. So KL, in terms of M and K, right, is KL is what? KL is KR, because this is R here. KR plus RL. KR plus RL. Yeah, that will give you KL. So KR, remember this here, K to R, the R is the midpoint there, so this is actually a half K. So R to K is a half K. K to R is negative a half K. Plus R to L. Remember RM, we have the full RM here, which is M minus K on 2, right? That is RM. Remember, L is the midpoint of RM, so that means that RL is going to be a half of the entire RM, M minus K on 2, right? So what do I have here? I have negative a half K plus a half M minus a half multiplied by a half. This K on 2 is a half K, right? And let me just do that. Let me just, instead of writing K on 2, let me just write a half K. So a half times a half is a quarter K. Nice. So we can see here this is negative a half. Okay. So we can see here that I have a half M, and it'll be minus, and a quarter was, remember, I have the K's here, minus a half minus a quarter. When the signs are the same, you add them and you keep the sign. So a half plus a quarter is 3 over 4. So 3 over 4. Okay. So now let's look at both of them and see, right? We want to know if RS is parallel to KL, right? RS, we had found that previously to be 1/3 M. Is it a third M? Plus a half K. No, minus a half K. Sorry. I wonder if that's correct. A third M plus OS. OS is a third M, yeah? A third M minus a half K. KL, we see in here, is a half M minus 3/4 K. Now what is the question? Prove that RS is parallel to KL. RS and KL. Right? So, how them two things could be parallel? Any idea? So obviously, if they're parallel, that means that if I take this M and I multiply it by some number, let me call that number X, then I'm supposed to get that M, right? So if I take a third and multiply it by some number, I am supposed to get a half. Yeah, and this number being the scalar number that we're trying to find, right? So okay, so that means that that number will be, I take the 3 and I fling it across, it will become, because remember this here, a third times X is really X on 3, right? So I fling the 3 across and it'll become 3 on 2. Alright, so okay, so if I had a third M and I multiply it by 3 on 2, I would get a half M. Alright, cool. So let's just see if that 3 on 2 will work for the k as well. And if I had a half k, right? Well, a half x, right? If for the k's, right? I had a half and I'm multiplying it by a number and I want to end up with 3 on 4, right? So you could tell here that x on 2, right, is equal to 3 on 4, so therefore x will be 3 on 4 multiplied by 2, which is 6 on 4, which is 3 on 2. So we can see here 3 on 2 is the scalar multiple, right? That if I take this guy, right, this guy here, 1 on 3m minus a half k, and I multiply this guy by 3 on 2, right? That'll give me what? 3 on 2 multiplied by a third, well, the 3's will cancel, it'll give me a half m, right? Minus 3 on 2 multiplied by a half will give me 3 on 4k, right? So therefore, the scalar multiple here, rs, this is rs, times 3 on 2 is equal to kl. Scotia, you understand what I did there?
Yeah.
Right? Shizzy, you understand what I did there? Yeah. Soraya and Caitlin, all you have any clue or you're sleeping? You have to feel the two of them sleeping, right? So we could see here that, alright, KL is actually equal to 3 on 2 RS. And therefore, they are parallel because they're scalar multiples of each other. So how did I find that they were scalar multiples of each other? Caitlin, did you understand how I found it out? Caitlin, hello, are you there? Do you understand how I found it? Alright, cool. All I asked myself is, okay, this is a third m, this is a third m, and this is a half m. So what number, I have a third and I want to multiply it by a number to get a half. So that means that x, so I used algebra to figure this out. Right? So that means that 3 on 2 is the number that I would multiply a third by 3 on 2 to get a half. And then I'll just check that 3 on 2. If I multiply a half by 3 on 2, I will indeed get 3 on 4. And so 3 on 2 is the answer. Nice. And no, I thought, I was confused because I thought that we were doing, we did some of these wrong maybe. But I checked it over and it's all correct. And even though this certainly doesn't look like a scalar multiple, thankfully we found one number that would have handled both m and k, and so they are scalar multiples, right? Right.